Hello students, welcome back to this new session on mathematics. This is going to be my last session, I suppose, but since I had planned to do my previous session to be the last session, but because of the explanation for that formula, it was very lengthy. It was about for 10 minutes or something. So again, continuing the problems in that same session would have made the video very lengthy. So I thought of making one more video on this problems. Okay, so let us see how to solve the problems using the Laplace transform. Okay, using the Laplace transform, let us see how to solve the linear differential equations. Okay, directly I have just shown you a problem here. It's written y triple dash plus 2 times y double dash minus y dash minus 2 times y is equal to 0, and it's given that y of 0 and y dash of 0 is 0 in the beginning. These are called initial values problems. All these type of problems where the initial values are given to you, they are called initial value problems. These are the initial values given to you, and you are going to work for the Laplace transform. I mean, using the Laplace transform, you are going to work for its solution. Okay, so let's see how to solve this. It's very simple. Let me adjust. Okay, now first, what should be your first step? First, you are going to take this equation and apply the Laplace transform. Take this equation and apply. However, it's written here, I'm not going to rewrite that same equation here. I'm going to directly take the Laplace transform to this equation. So applying the Laplace transform, you have Laplace transform of y triple dash plus 2 times y dash minus y dash minus 2 times y is equals to the Laplace transform of 0. Or you just separate all the terms. Laplace transform of y triple dash plus 2 times Laplace transform of, y double dash here, y double dash minus the Laplace transform of y dash. 2 is constant, that's why I have written it outside. Minus 2 times again a constant, Laplace transform of y is equal to the Laplace transform of 0. You all know it is 0 only. Okay, or you can just use the formula and verify it is 0. Okay, so now let us discuss how to expand all this. You are going to expand each of this bracket using that formula which I have given you at the end in my previous session. Okay, the Laplace transform of y triple dash we have to expand using this formula. I have written it on the top, the previous session formula. Okay, so just see here. The Laplace transform of y to the power nt means the nth derivative of t is equal to the power of s to be n, y bar of s, and so on. Yes, using the same thing we are going to do it here. Y triple dash means n is equals to 3. Y double dash means y n is equal to 2. Y dash means n equals 1. Okay, taking the values for n is equal to 3, 2, 1. Let us expand each of this. Okay, now here for n is equal to 3, this takes the value s cube. Yes or no? S cube y bar of s. Let me write a square bracket here. Okay, because I am doing the expansion for the first term. Okay, minus s square. Second term is s to the power n minus 1, so it becomes s square y of 0 minus s it will be now because n minus 2 becomes s. Okay, because n equals 3 here. Y dash of 0 minus s to the power 3 minus 3 it will be this time. Just see, 3 minus 3 turns 0, is it not? So s to the power 0 is 1. So you will have y double dash simply. And further there are no terms because there is no s at all. You are going to stop it here. This is the expansion for y triple dash, Laplace transform for y triple dash. Plus 2 times, now n is equal to 2. Okay, so it becomes s square y bar of s minus s y of 0. Just apply the formula, nothing else. Okay, minus s to the power 2 minus 2 it will be the next term. So it will be 0 y dash of 0. Okay, y dash of 0. Done? Plus, it is minus there again, minus the Laplace transform of y dash of, so n equals 1, so to be s into y bar of s minus y of 0 minus 2 times the Laplace transform of y, it will be y bar of 0, y bar of s, y bar of s, write it. This is the last term is equals to 0. Now after we are done with that expansion, I hope the expansion is clear to all of you. First s cube y bar of s minus this expansion, I hope it is clear. Again for n is equal to 2 you are going to do it. For n is equal to 1 you are going to do it, and there is no expansion as such. Just directly write the Laplace transform of y as y bar of s equated to 0. Once you are done up till here, you are going to substitute the values given to you in the problem. y of 0 and y dash of 0, they are both 0, but whereas y double dash of 0 is 6. Let us substitute that. So this is 0, only here it comes 6. Again this is 0, and even this is 0. So let us do the substitutions. You have s cube y bar of s minus 6. Because these two are zeros, so these two are zeros, only you will have this. Plus 2 times s square y bar of s. Now this is 0, because the given thing is like that. Minus, similarly this is again 0, s into y bar of s, minus s into y bar of s, minus 2 times y bar of s is equal to 0. Like this it will be. Done? Now, collect all the y bar of s one side. Okay? All of you collect the y bar of s one side. So you see where and all you have y bar of s? It's here, it's here, it's here, and it's here, and only one single constant, that is 6. So y bar of s, if I take the quotient for the first term with y bar of s is s cube plus 2s square in the second term. Here it is minus s. Here the quotient for y bar of s is minus 2. Minus 6 is equal to 0. Further you have to simplify this. Y bar of s into s cube plus 2s square minus s minus 2 is equal to 6. Or separate your y bar of s from here. You will have 6 divided by s cube minus 2s plus 2s square minus s minus 2. Now see this denominator, s cube plus 2s square minus s minus 2. It can be written as, I can take s square common from here, the first two terms, you will be left with s plus 2. I can take minus 1 common from the next two terms, s plus 2 is left. Okay, so we will have s plus 2, s square minus 1, or it can be written as s plus 2, s plus 1, s minus 1. So I am going to substitute it here. So this will be 6 divided by s plus 2, s plus 1, s minus 1. Okay. So this is our y bar of s now. Okay. Once you arrive at this stage, you are going to take inverse Laplace transform. Okay. I hope it is clear to all of you. Right from here, we are going to apply the Laplace transform to the entire equation, separate all of the terms, then take individual expansions using that formula for the Laplace transform of the derivatives of y. Okay. For individual terms. Do all this. Separate your y bar of s. Okay, separate your y bar of s after substituting the given values for y of 0, y dash of 0, y double dash of 0, all that. You just substitute it, try to simplify, separate your y bar of s from here. Once you arrive at this stage, you can apply the inverse Laplace transform. But before that, how you are going to get the inverse Laplace transform? See here, they are all simple brackets in the denominator. I'll use the partial fraction method. Okay, I will use the inverse Laplace transform by partial fractions and solve it. Okay, let's do that. So you had got your y bar of s to be, 6 divided by s plus 2, s plus 1 and s minus 1. So you can write this as a divided by the first bracket plus b divided by the second bracket plus c divided by the third bracket. Is it? Okay. Now let us simplify this to get the values for a, b, c. The denominator of a does not contain what? S plus 1 and s minus 1. What is absent in the denominator of b? S plus 2 and s minus 1. What is absent in the denominator of c? S plus 2 and s plus 1. Right? Now just put s is equal to minus 2. Minus 2 if you put, it will be 0 here, it will be 0 here. When you put s is equal to minus 2, what will happen? It will be minus 2 plus 1. It will be minus 1, and minus 2 into minus 1, minus 2 minus 1 becomes minus 3. Minus 1 into minus 3 is, left hand side is 6 only. So minus 1 into minus 3 is 3a, or a equals 2. This is the value for a. Similarly, now let us put s is equal to minus 1. This is 0, this is 0, this is minus 1, plus 2, it will be plus 1, minus 2, it will be minus 1, minus 2. So you will have minus 2b on the right hand side. Left hand side is 6 only. So b is minus 3. B is minus 3. Similarly, put s is equal to 1. This is 0, this is 0. You will have 6 is equal to 6c. Just see, 1 plus 2, 3, 3 2 is 6, 6c, or c will be 1. Just work for all the values for a, b, c. Now let us substitute. Y bar of s is equal to 2 divided by s plus 2 minus 3 divided by s plus 1 plus 1 divided by s minus 1. Now take L inverse on both the sides. Therefore L inverse of y bar of s is equal to L inverse of 2 divided by s plus 2 minus L inverse of 3 divided by s plus 1 plus 1 L inverse of 1 divided by s minus 1. Okay, take L inverse. So 2 is constant outside. L inverse of e to the power s to the power L inverse of 1 divided by s plus 2 is e to the power minus 2 minus L inverse of this 3 is constant, e to the power minus t it will be, plus e to the power t. So L inverse of y bar of s is nothing but y of t, which is your required solution. Okay, this completes the solution for this problem. If you still have any doubts, do ask me in our WhatsApp group. I'll continue with one more problem in this session only, so that it will end up my module. Okay. Yes, here is one more problem for you. Solve y double dash plus 4y dash plus 4y a is equals to e to the power minus t, given that y of 0 is 0 and y dash of 0 is also 0. Let us solve this solution. Solution is same as how we did in the previous example. Take the Laplace transform throughout. Okay, now separate the Laplace transform for each of the terms here. Laplace transform of e to the power minus t is 1 divided by s plus 1. Write it. Now expansion of this using that formula. N is equal to 2 now again. This is the expansion for the first term, plus 4 times outside. 4 is outside. S into y bar of s minus y of 0 plus 4 times y bar of s is equal to 1 divided by s plus 1. Now just substitute the values for y dash of 0 and y of 0. This is 0, this is 0, even this is 0. So we'll have s square y bar of s only in the first term, plus 4 times s into y bar of s in the second term, plus 4 y bar of s in the third term, 1 divided by s plus 1. Okay. Now I will take y bar of s common. You are left with s square plus 4s plus 4 is equal to 1 divided by s plus 1, or y bar of s is equal to 1 divided by s plus 1, s square plus 4s plus 1 plus 4. Okay. Now what is y bar of s here? It is 1 divided by, just see this, the bracket over here is nothing but s plus 2 the whole square, is it not? So apply the partial fraction method and solve it. It's very simple. Your y bar of s is nothing but 1 divided by s plus 1, s plus 2 the whole square. So a divided by the first bracket plus b divided by the second bracket, because the bracket is repeating once more. So one more term, s plus 2 the whole square you are going to do as per the rules of the partial fractions. Okay. Once the bracket is repeating itself, you also repeat it. Okay, in your expansion. Okay, first you will take it linear, then next term you will take it the double of it. Okay, that you will take it actual this. So the number of times it is repeating, that many number of times you will take the brackets. Okay, so that you should know. So I'll just take the left hand side to be 1, not y bar of s. Here left hand side is 1 over here. So 1 is equal to a. What is absent in the denominator of a? The complete denominator should be this. What is absent? A, s plus 2 the whole square is missing. In denominator of b, s plus 2 and s plus 1 they are missing. In the denominator of c, what is missing? in the denominator of C, you see that 1 minute. Yes, I'm just using, okay, so C into what else is left here, I'll take that one. So it is, yes, in the denominator of C, S plus 1 is missing, write it, okay. So once you are done up till here, let us work for the values for A, B and C. Put S is equal to minus 2. If you put S is equal to minus 2, this and this turns 0. You will have minus 2C here. So 1 equals minus 2 plus 1. Minus 2 plus 1, it becomes minus C, or C equals minus 1. Now put S is equal to minus 1. So this turns 0, this turns 0, minus 1 plus 2. Plus 1 whole square is 1, so A equals 1. You get the value for A to be 1, okay. Now you put S is equals to, or you just compare the coefficients of A and B. You compare the coefficients of A and B, coefficient of S square you should say. Where and all you get S square. S square you get it here, as well you get S square here, because S into S gives you S square, okay, into B, okay. There is no S square with C. Okay, so only with A and B there is S square, and there is on the left hand side there is no S square. So therefore you just write here comparing the coefficients of S square, okay. You will have A plus B to be equal to 0. So A plus B is equals to 0 means A is 1, so B should be minus 1. So you get the values for A, B and C like this. Once you get the values for A, B and C, let us substitute them in y bar of S and get the solution, okay. So yeah, I'm going to write it here itself. Okay, so the value for A was 1. A is 1 divided by S plus 1. B is minus 1 divided by S plus 2. C is also minus 1 divided by S plus 2 whole square. So this is your y bar of S. I want y of t from here, so apply L inverse. L inverse of y bar of S is equal to L inverse of 1 divided by S plus 1 plus minus L inverse of 1 divided by S plus 2 minus L inverse of 1 divided by S plus 2 whole square. Okay, see that. I hope it is seen now. Okay, now see L inverse of 1 divided by S plus 1 is e to power minus t minus e to power minus 2t minus 2t, okay, minus here it is e to power minus 2t will be there, but L inverse of 1 by S square it will be here, okay, by the property, okay. I hope you remember what to do with this. Whenever S plus 1, S plus 2 whole square, in place of S simple S you have got whole square or something like that, then you have to use e to power minus 2t, there is nothing left there. So now here if you simplify it will be e to power minus t minus e to power minus 2t minus e to power minus 2t into t you will have, okay, or further simplification will give you e to power minus 2t minus e to power minus 2t into 1 plus t. This is the simplified form of your y of t. So y bar of S is that L inverse of y bar of S is y of t. This is the solution for your problem. If you still have any doubts, do ask me in my WhatsApp group. Till then, thank you. So this completes our module. In my next session, I'll be continuing with the new module. So all of you, please check all my sessions, all my videos, so that it should not be a problem for you when I conduct the test. Okay, thank you.